Uh, Hello, this is Krishna Teja. My project is password-based authentication and encrypted data storage in untrusted environments. So we'll talk about the summary of our project. Um, like passwords are widely used for client to server authentication as well as for encrypting data stored in untrusted environments. So such as cloud storage, websites and applications, etc. Uh, both authentication and encrypted cloud storage are usually discussed in isolation. In this work, we propose a auth store, a flexible authentication framework that allows users to securely reuse passwords for authentication as well as for encrypted cloud storage at a single or multiple service providers. Uh, Users can configure how secure passwords are protected using password stretching techniques. So, uh, the framework we are going to propose is AuthStore. So, we'll talk briefly about how it efficiently secures the password in untrusted environments, etc. So, let's discuss about the introduction. So, the introduction of this project is like for authentication as well as for protecting digital assets, passwords are simple, usable and commonly uh, used solution for protecting the data. So obviously the use of passwords encourages the reuse of passwords for multiple services. However, this has an important security and privacy implications, since a leaked passwords gives an attacker access to multiple services. Uh, a service provider often fail to store a user password securely. Uh, for example, a passwords are stored in the plain text or weakly protected. So these are all the example for the service providers after fail to store user password securely. So in general, it is unclear for users if and how service providers keep your passwords confidentially, and even worst case scenarios, a service provider may itself be a malicious and use a user password to impersonate a user at other service providers. For instance, a web service provider can read out the user password straight from the login page by recording keystrokes and gain knowledge of all passwords entered by the user. So in the same way, the passwords are not only used for authentication but also to encrypt data that can be stored in the potentially untrusted environments. So for example, a websites that are weakly secured. It is important to remark that a password-based authentication protocols should not leak the password to ensure that uh, that storage providers are unable to recover, unfortunately. So unfortunately the discussion of this secure password based authentication schemas is often neglected, which compromise secure data encryption. So let's talk about the system requirements. So the system requirements are simplicity, secure password storage and secure authentication and data storage. So we'll talk about the simplicity. So the simplicity is the only information required by the user to authenticate and to register at the service provider is username and the password. So no other mechanism or service such as a trusted key server is required by the user. And the second thing is secure password storage. Secure password storage means the user must be able to configure how much an authentication password is strengthened before it is stored at the service provider. and the user is in the control how strong a password is secured from offline dictionary attacks. And and other thing is secure authentication. So we'll talk about this. The user authentication protocol must ensure that no information about the password is leaked to any other party. For example, dictionary attacks are impossible, right? So this includes that a service provider should not be able to learn any information about the entered password. Uh, for example, we'll talk about this as an example. A mistakenly entered password used at different service provider. An attacker who compromises a service provider must not be able to impersonate that using the stored authentication data, right? So, and the last thing is data storage. So if a service provider supports data storage, a user must be able to securely reuse the authentication password to protect the data without the risk. uh, and our we'll talk about our approach. So our approach is we propose a framework like Auth for password-based authentication and data encryption, where service providers are necessarily uh, trusted in order to strengthen the user password. We use a key derivation function KDF to derive a strong base key. In general, a KDF takes set of parameters uh, that determine how strong a derived key is protected from dictionary attacks. So the KDF parameters can be chosen by the user to control the trade-off between authentication time evaluation and the password protection against possible attacks. So we use a simple but flexible method to derive an arbitrary number of user keys from a base key. A user key can then be used for authentication, data encryption, or other purposes. This also means that a busy key can safely be reused for multiple purposes. So this is the approach. And we'll talk about the system model. So in our system model, we have two main entities. The one is the user and the other one is service provider. So the user owns one or more user accounts at one or more service providers. In the same way, the user communicates with the service provider through a trusted client software. A user can be able to authenticate a service provider using the username and the password. So the service provider is responsible to manage a set of user accounts and stores all necessary parameters that are needed for the user authentication. So we'll talk about the threat model. Threat model is in our approach, we use key stretching to protect the user password. So external attackers may learn or guess the username and try to impersonate the user. So the attacker may try to perform an online attack. So guessing the user password, the attacker may perform a man in the middle. So attack to monitor the authentication protocol. Moreover, the attacker may gain access to the service provider, in which case the attacker is treated the same as a service provider. So this is the threat model. So our solution. Uh, so a key stretching provides a strong base key. We already discussed earlier, which can be used to generate a set of user keys, and user keys can be used to authenticate and to secure the data storage. So a password stretching, here we can see K is equals to KDF, where K is the derived key. To strengthen the user password, a KDF is used. Uh, and So we'll talk about this diagram. So what it tells exactly is, like we can see, using a KDF. So here KDF, the user derives a base key K from the user password. From the base key, an arbitrary number of user keys can be derived. User keys can be derived. These user keys can be used for authentication. So these arbitrary number of user keys. So these keys can be derived from the base key. So these user keys can be used for authentication. This is for authentication. This is for encryption. So this is K data. Okay. So using KDF, the user derives a base key. So the user is already derived the base key from the user password. So using this password, the user can able to derive the base key from the user password. So from the base key K, an arbitrary number of user keys can be derived, such as K authorization and K data. The purpose of K authorization is for authorizing the data, and for K data is for encrypting the data. So and it will be stored in the database. So this is exactly what it tells about the whole. And in the secure data storage, if the auth service provider offers data storage, the user may ensure data confidentially by employing encryption techniques. For the encryption, the user generates some user keys parameters such as uh, PU, PU1 data, and derives a new user key K data. To minimize the computational cost, computational cost, the base key parameters PK that are used to derive the authentication key pi can be reused. So, and we'll talk about the registration and authentication. For authentication at a service provider, the user derives the authentication key and the service provider derives the verification values. And also to register for the user account, the user may choose the parameters such as P and derives the login key and uploads them to the service provider. And also the service provider authenticates the user by providing a mutual secure session key. And we'll talk about the password change and key update and account reset and security analysis. We'll talk about password change and key update. To change the user password, a user choose new key parameters and derives value from the new password at a successful authentication with old password. So if encrypted data is stored at the service provider, a new encryption key data is generated, and K is re-encrypted with K data, and P data is uploaded at the service provider. And also we'll talk about the account reset. Account reset is in case the user forgets the username and the password used at certain service provider, traditional recovery methods are applied. For example, the user can request an account reset through trusted third-party channels such as an ordinary email account. And we'll talk about the security analysis. In this section, we analyze the security of auth store. Moreover, we'll describe about novel parameter attack that targets authentication schemas that include password stretching. And how it works efficiently, like we already discussed earlier, password. So as we discussed earlier, using KDF, the user derives the base key K from the user password. So the user is going to derive a base key K from the password. So from the base key, the arbitrary number of user keys K data and K auth. What is the purpose of K auth? K auth is used for authorizing the data, and K data is used for encrypting the data. So uh, and after encrypting, the data will be stored in the database. So this is about this diagram, and we'll talk about the password management. So to make attacks difficult, password managers can use secret sharing to store the master key of the password manager, or use decoy passwords. And Passpet uses key stretching to protect passwords on secure, reliable cloud storage, but only assumes the service provider is trusted. So, and to provide a complete authentication solution, and to demonstrate the flexibility of AuthStore, we present a password manager that can securely store arbitrary credentials at any AuthStore provider. And to design the design of the password manager is follows: to securely store key material, the password manager uses password protected encrypted storage, as described in the section. and and conclusion is, um, like Authstore is a secure password-based authentication method that allows users to reuse passwords for multiple service providers and for secure data encryption. And we presented a compact asymmetric PEG protocol that requires fewer communication messages that other than PEG protocols, that allows users to securely store arbitrary credentials such as web login passwords in the cloud. So this is about the conclusion uh, about this project, and these are all the references. And thank you so much.